Next topic we're going to be looking at is overview of computing systems. So within the overview of a computer system, we can say that a computer system is a combination of hardware and software components designed to process data and execute instructions to perform various tasks. It refers to the physical components like CPU, memory, input devices, and output devices. So the overview of a computer system is not just talking about the computer system itself on its own. It's talking about the system, the internal structure, and the peripherals that come with the computer system. So within that, we also look at something like the CPU, which is the central processing unit, the memory, which the memory could be the primary memory or the secondary memory. And we'll also look at the input devices and the output devices. So we'll look at the constituent elements of a computer system. So the first thing we're going to look at is the hardware. And how do you actually define or know the hardware, or what a hardware is? So you should keep in mind that the hardware can be referred to as the tangible body of a computer, what you can actually see and touch, like the solid part of the computer, which you can see, you can touch, you can, break if you want to, but you shouldn't. So the hardware is the part of the computer that is visible for you to see. So the hardware is not just about the casing that you can see, even the things that are inside, which if you open them, you can actually see them, you can touch them. That's where the tangibility comes in. So we also have the software. The software is like the brain of the computer, which it's the one that gives the computer instructions. It's the software that gives the hardware the instructions. Similar to the way the brain works in a human, there are certain things called electrons that actually send out signals within your brain. And these things are the things that actually communicate with the rest of your body, similar to how the human body is, which we have the hardware, that's your skin, the bones, the eye. That's also the hardware. So there are also software, just like the human body have electrons moving around the body, sending signals to the brain, sending to the brain, and also receiving. So that's exactly how the computer works. So we can look at the characteristics of a computer. The first thing we'll look at is the speed. Now, what even differentiates a computer, is a specific type of computer with another type of computer, is actually the speed. For example, a supercomputer can perform trillions of instructions per second, while some other kinds of computers, like let's say the personal computers, can perform, let's say, just 1,000 per second, or let's say 100,000 or 1 million per second. But the supercomputer, so the speed is actually what we can use as the characteristics. The accuracy. Computers are meant to do things more accurately. There are some that are accurate and there are some that are extremely precise. Now, accuracy is what you use to know that, oh, this is a computer. For a human being, mistakes are bound to happen. But for a computer, there is no room for error, because exactly what was programmed into the computer is what you get. Diligence. The computer is always able to complete the task it is being given on time without having to flare off, maybe lose focus and start doing something else. The versatility as well is also useful. A computer can do a whole lot of things. You can see that a human being, for example, is able to draw. That same human being may not be able to do mathematics, but a computer can do multiple things at the same time. Memory. It has both the secondary memory and the primary memory. The automation as well, which is the ability of the computer to be able to do things on its own without being instructed on what to do. As long as you've given it the initial instruction, you don't need to keep reminding and telling it what to do. Logical reasoning. Computers are more logical than human beings in this case. I know I like using the comparison between a human being and a computer, but it's for a computer, it's more logical. If it knows that this particular thing should be in this particular way, it is going to give you that result that same way without veering off topic. Consistency. As long as a computer has been programmed to do a particular thing in a particular way, you're always going to get the same output, the same quality, as long as the computer is in good condition. We also have the remembrance power, the ability to store things and then you reuse them without having you to input something new. But human beings, definitely, we can forget things. So differences between the hardware and the software. Firstly, let's look at the hardware. tangibility. Now, the hardware is tangible. You can see the hardware, you can touch the hardware. And we can also look at the functions. The hardware carries out the instruction provided by the computer. So it carries out the instructions provided by the software, actually, because the software is the one that keeps the instructions and makes the rules, and then the hardware only knows that it's supposed to follow the rules created by the software. So examples of the hardware is the monitor, the keyboard, mouse, CPU, the memory, the storage, which could be SSD or HDD in this case. So let's look at the software. Software is intangible. It's like software is something you can't see. It's just like the way we have the wind, something you cannot see, but you can feel it. But the thing is, in this case, for a software that is in a computer, you can see the performance of the software from how the hardware is operating. So the hardware is the tangible part, but the software is the intangible part that controls the hardware. So the functions of it is to direct the hardware on the task it's supposed to perform. And examples of this software is the operating system, the application programs, the programming languages, and most all softwares have programming languages. It's actually the programming languages that are used to develop these softwares that we actually use to instruct the hardware on what to do. Okay, so examples of hardware devices, we have the internal hardware and we also have the external hardware devices. So essential computer hardware and their uses, that's the keyboard. The keyboard is used for inputting data. When you want to, let's say, input numerical, alphabetical, even mathematical functions into the computer, you need the keyboard. The mouse is used for clicking and scrolling. We have the touch screen, depending on the device you're using. Not all devices are touch screen, but the touch screen acts in most cases as a combination of the keyboard and the mouse, because in most cases, if you have like an on-screen keyboard, you can actually type from the screen without having to use the actual hardware keyboard. So, and the touchscreen is very, very versatile. You can do a whole lot of things with the touchscreen. We have the scanner, the webcam, the microphone. The microphone is actually used for storing audio in a computer. Like, for example, you are actually listening to this tutorial right now. The tutorial I'm actually giving, I'm using a microphone, and the microphone is what is receiving the signal in the audio in form of electrical signals and then storing them. And then we have the webcam, which you can use for video conferencing, use that for taking pictures and for any other thing in between. So the difference between the input devices and then the output devices, the input devices are used to send data or commands to the computer for processing, while the output devices, on the other hand, display or give the output of what the input devices had given initially. Okay, so we'll look at the classification of the keys on the keyboard. We have typing keys at A to Z and 0 to 9, which you can use for typing alphabetical things and can also use it for typing numerical things, which is between 0 to 9. The control keys, which we can call them the special keys, but in this case, they are not classified as special keys, but they are called the control keys, which are the control, that's CTRL and then shift. We use them for certain functions. Let's say you want to capitalize a particular alphabet without using cap locks, you can actually use the shift to do that. We have the function keys, which ranges from F1 to F12, which the function keys have their own special functions to do. Some laptops, the function keys can be used to increase the brightness of the screen or to change a particular setting in the software. We have the arrow keys, which can be used for going up, going down, and also have the home key. Now, the arrow keys, assuming you are playing a game and your game needs, let's say you're playing a racing game and you need a game that, or the game is a racing game or could be a football game, and you need to go to the left. That's where the arrow keys come in. You can actually use those to move left, right, go up or down. The number part, not all keyboards have the special number parts. That's why it's optional. There are certain keyboards that are actually smaller that just have the normal keys and still have the numbers above the normal alphabetical keys. But there are some keyboards that have number keys separately, apart from the ones that are just below the function keys. And we also have the special keys, which are like the media keys, where you can increase the volume, you can reduce the volume, you can mute your system should you want to. So we're looking at printers. We have images of printers here. So first printer we're going to look at is the inkjet printer, which the actual mode of operation is for it to spray ink on a paper that it is actually trying to write on. That's actually how the inkjet printer works. We also have the laser printer. The laser printer uses lasers to actually print on a piece of paper or on any surface. It could be a canvas, it could be a banner. That usually uses lasers to do that. And then we have the line printers, which uses lines to plot text, could be graphics, could be numbers or images on a piece of paper or a piece of canvas. Next thing we'll look at is components of CPU. The CPU, or central processing unit, is the brain of the computer. I know we actually indirectly called the software the brain of the computer, but the main thing that we can classify as the brain of the computer is the central processing unit, because it's the central processing unit is the one that processes things, that takes up all the logic. So the software is even controlled by the CPU, but the CPU needs the software to run. So the components of the CPU is a control unit, which in short we call CU, the arithmetic logic, which is in charge of doing all the logical parts of functions of the CPU, and we have the registers, which in this case is most often, in most places, universally is used for keeping certain tiny informations that can be used by the CPU itself. Okay, so the next topic we're going to look at is the storage unit. A storage unit is a digital space for storing your files. Take the storage unit to be a file cabinet where, let's say in an office where you want to keep your files. Let's say you have office files and then you are looking for some way to keep it safely so that next time you want to use it, you can easily access it without it being damaged. That's how the storage unit is. But in this case, you could call it a digital filing cabinet for organizing all your computer stuff. So let's just look at it as the digital part or format of a file cabinet. And a file cabinet is used for keeping files, which in most cases, the first file goes in first, and then the last file is usually the one on top, depending on how you choose to arrange it. You can also do the same thing when it has to do with the storage unit of a computer. Okay, so the next thing we're going to look at is the types of storage units. Primary storage unit, which in this case, we've talked about this. I mentioned this earlier on, which I mentioned the primary storage and then the secondary storage. So the primary storage, which directly communicates with the CPU, is called the RAM, which the RAM is short for random access memory. So the RAM is very crucial. It's like the short term, or let's say in this case, it's called the temporal storage, where information can be stored for a very short period of time. Why we call it short-term storage is because immediately the system goes off. Let's say you shut it down. Everything that was stored there will be wiped out. So it only keeps files that is working on at the moment. For example, if you look at, let's say you have a DEX, and you have a file cabinet, which the file cabinet in this case would be the secondary storage, which could be the HDD or the SSD, where you keep things permanently. Now you have a table. The table is where you actually work with files you need. And whenever you are done for the day and about to go back home from work, you could decide to clear your decks and then keep the important things you need to keep in your filing cabinet, which in this case is the digital one, which is the secondary storage. And then the temporal files you were working with, you could choose to discard the ones that are useless to you. So in this case, it could be that the cleaner comes in the morning and then cleans your table of anything that is there, which should not be there, which should be put in the trash. So that's exactly how the primary storage works. So things that are there, if not properly stored, are going to get deleted or be lost. So what is ROM? ROM in this case stands for read-only memory and is a type of computer memory that stores data permanently. Now, things that are stored here cannot be altered. They are exactly the way they are going to be from the very first day which they were introduced into the storage. Now, the ROMs naturally is used to store instructions for your computer, for the operating system, for the CPU. Now, the instructions, you may ask, where are they stored? They are not stored on your hard drive. They are not stored on your SSD. They are stored in the ROM. These are storages that are for things that should not be altered. So it would be unwise for the developer of a computer or a device to actually go and store information that can be useful, and if not found, the system will not function properly. So that's the reason why the ROM is necessary. And it's a different kind of storage from that of the HDD, but it still stores files permanently. So we've come to the end of this particular slide. And in this particular slide, we've talked about the overview of a computer system. We've looked at the constituents, or you can call them elements of a computer system. We've looked at the characteristics of a computer, which we looked at the accuracy, the speed. We've looked at the differences between the hardware and the software, knowing that the hardware is the tangible and the software is the intangible part of the computer. And we've looked at examples of hardware devices. We've looked at external hardware devices as well.